Hi there, my name is Duncan, and in this short video, I'm just going to share with you one of my techniques that I use to remember the laws of sets. So I want to begin with what I refer to as the subset laws. All right. Now, if you're given two sets so if you're given two sets, so let's say set B and another set A that is inside. All right. So I put set B as set A here. So set B will be outside and set A to be inside. So let's say we have these numbers here and the three outside just to represent the universal set. So if you're told to list down the numbers that are in B here, so what is set B? So set B, according to what we can see here, set B is 1 and 2, right? So these are the two values that are in B, and then in A, what we're going to have is only a 1, right? So if you're told to find the intersection, all right, then the universal set, this 3 does not belong to any of the sets. So what is A intersection B here? So let's begin with A intersection B. So clearly we can see what is found in both of these two sets is a 1, right? And then A union B, if we take a look at this, we have numbers, it's 1 and 2, right? So now using this principle here, you can remember all what we call the identity laws, all right? And I want to give you this statement here that if you have two sets that are subsets, all right, let's say in this case we have A and B, and we know that A is a subset of B. So what does it mean? For if we have a subset relationship, here's what I want you to remember, that if you're uniting the two sets, okay, so that is meaning we're uniting, we're saying A union B, which is also the same as B union A, right, according to the associative law. So because of this, if you're uniting them, so long as there's a union here, what you get is the bigger set. So now, if you look at here, we have A union B. Which one is the bigger set? Obviously, B is the bigger one, then A is the smaller one. So if you're uniting them, the answer will always be the bigger set. So the bigger set that we have here is B. So A union B is simply going to be what? To be B. Okay. Then if you have the smaller set, okay, if you're intersecting them, so let's say A intersection B, if it is an intersection, you're going to get the smaller set, of which the smaller set here is A. All right, so A intersection B will simply be called what? A. Now let us take a look at the identity laws that you already know, and using this principle, let us prove them. So what we have under the laws, the identity laws, we have, for example, A intersection the universal set. Now, if you look at the universal set, any set is a subset of the universal set. So in other words, all sets are found inside the universal set. So if you have the universal set, if you just see the universal set, you must know we are talking about the identity laws. So in this case, let's try out this. What's going to be the answer? I don't want you to master this. I just want you to know about the subsets. So here's the thing. If you're uniting, so we are saying A intersection universal set. So clearly here we know these are subset laws because why? A is inside the universal set. Any set is inside the universal set. So now what did I say? If you are intersecting them, what do we get? We get the smaller set. So which one is the smaller set here? It is obviously A. So the answer here is going to be A. If you are finding the union, let's say we say A union, the universal set. Let me use E. What is going to be the answer here? So the bigger set here is the universal set. So it's going to be here. Okay, this is going to be our answer. So this will work for anything. The last one that I want to talk about is the empty set. Now, if you see an empty set as well, what should come to your mind are subset laws. Why? Because inside every set is an empty set. So for example, if I tell you to give me the subsets of A, inside every set, the first set is the empty set, then we have A and so on and so forth. So the empty set is found in every set. It's the opposite of the universal set. Every set is found inside the universal set, but the empty set is found inside every set. So if you have the empty set, let's say A intersection the empty set. So here you take a look at them. What should come to your mind whenever you see an empty set or in a universal set? What should come to your mind is subset laws. So here we have the bigger set as well. So this one here will be the big set in this case. Then the empty set will be the smaller set. So here we're intersecting them. What's going to be our answer? It's going to be an empty set. What about if you're uniting them, A union empty set? What are we going to have? Obviously, here we're uniting them, so we get the bigger one. So this is just simply going to be A. So this is all that I wanted to show you about the rules of sets. So use this principle, go and check out all the identity laws. I've got this. The last one that I want to talk about is the aspect of the complement laws, okay? Another technique. So for the complement laws is when we have a complement, okay? You know what is A? The opposite of A is simply a complement. So complement is simply what is not in that set. So if we're talking about a complement, it means what is not in A, right? So let us take a look at this. What do we do when you have complement laws? So the first one that I'd love to share with you is that when complement laws are either uniting or intersecting, I refer to this one, the normal set, let's call it light. Then the complement, what are you going to call it? What's the opposite of light? It's obviously darkness, right? Now, let's use these two principles to always remember this. If I say A intersection A complement, now what's true about intersection? Intersection means common, right? So in other ways, we're going to ask ourselves, what is common between light and darkness? This is going to help you so much. What is common between light and darkness? What is found in light and also in darkness? Obviously, there's nothing. So nothing simply stands for an empty set there. What about if you're uniting them? A union A complement. Now, uniting them, you're bringing them together. This world is made up of two things. We have the light and we have the darkness. So if you bring them together, that's what forms the whole what? The whole universe. So this is how I want you to remember this. So when it comes to the complement laws, we have light and darkness. Intersecting them, we're finding what is common, of which there's nothing. When you're uniting them, what we get? When you're uniting light and darkness, we get the whole universe. All right. Then the last one that we have obviously is concerning the universal complement. Now, remember I was saying the universal set is what? The universal set is everything, isn't it? It's the whole world. So if you remove the whole world, which is the complement, right? Remove the whole world, what do you remain with? You remain with nothing. What is the opposite of nothing? An empty set complement. What is the opposite of nothing? The opposite of nothing is everything. So it's going to be the universal set. So always look at the complement as the opposite. So what's the opposite of everything? It is nothing. What is the opposite of nothing here? It is everything. So using this, I want you to get this, and I want you to go back to the aspects of sets. Then in the next video, I'm going to show you now how to evaluate everything, and you're going to enjoy this so much, and everything shall flow well for you. So thank you so much. Do subscribe to my YouTube channel, Duncan Mutalange. You just click on the subscribe button so that you can be updated on the new videos that I'll be sending. So thank you so much. I hope this video was helpful. God bless.